Okay, let's say that we have this problem and it says engineers must consider the breadths of mill heads when designing helmets, and we are given a mean of 6.8, so I would write where the mean falls, and a standard deviation. I'm not going to do anything with it, but I'm just going to write it over here. And it wants to know the cutoffs here of the lowest 2.7%, or that would be 0.027, or this upper 2.7%. Okay, now remember when you're looking at these values, what you're trying to find is the negative z and the positive z. These will be the same numbers because this is symmetric. But you want to be careful because this one's a little easier to find because you actually just put in that area, the 0.027. This one, remember, you go from the bottom all the way up to that value. So this is actually 1 minus 0.027, which is 0.973. And you'll see where I'm going to use these values. So the formula for the z, how do you find z? Well, it's z equals your x minus your mean over your standard deviation. I think they give me the mean. I think they give me the standard deviation. I can find my z based off of this probability. And this is how I do this in Google Sheets. So I grab the Google Sheets, I go to the Compute tab. This is where I don't have to look up in a table. So this is the standardized z-value, which means the mean has to be 0, standard deviation has to be 1. This other stuff doesn't even matter, okay? But then I created a function here that says equals NORMINV. This is going to give me the z-value for this area. So I need to put it in 0.027, okay, and notice what the formula is doing. So it wants the area, okay, that's first, the E8 cell, and then the 0 and the 1. So only those 3 cells matter. And I get negative 1.9268. So what I can do here, negative 1.9268, I believe it was. Remember, this is a standardized mean, so really this is 0. But what I want to do is I want to know, well, if this is 6.8, what is this x value? Well, remember this formula right here. Couldn't you plug in negative 1.9268? I don't know what x is because that's what I'm trying to solve. And do my algebra stuff that all the crazy kids are doing, right? So the algebra is just simply multiply both sides by the standard deviation and then add the mean. Okay, so that's just going back in algebra class. That's ugly, but that's a 6.8. So again, I'm kind of lazy. Why not put this in a Google Sheet so I can reuse this? And you're going to see that's what I did down here, so I'm going to redo it, is I added these two because these are for this problem. How do I find x? Well, I just said right here, take z times the standard deviation plus the mean equals z times the standard deviation plus the mean. And when you do that, you will see that you will get the correct answer. Now, that's all fine, but what about this other side? Well, if you are really understanding the normal distribution, which I hope you are, that this is symmetrical, if this is negative 1.9268, what is this? Positive. I mean, that tells me if you knew that, you really understand the symmetry. If I'm cutting off 2.7% below or above, the z-values don't change. But then what I need to do here, what you saw me write out, was this was the 0.973. Watch this number right here. It didn't change, just the sign changed. But you see, now I've actually created this. So I can work any problem. If I get it wrong, I can just change these numbers. So this is where you try to learn to use Google Sheets. You can add stuff in here, to set up. This is probably one of the most important formulas, so you can find z-values based on probabilities.